Hey everyone, this is Java Class 1.1, How Computers Work.
So then the first logical question to ask is, what exactly is a computer? Well, at the very bottom of it, computers are devices that do things with data or information. Computers can do so many things, from letting you send and receive emails, to playing games, to watching videos. But the only reason that they can do those things is that some people came together and created the instructions for doing these things, and they gave it to a computer. That's what we call computer programming. It's basically giving the computer the instructions it needs to do something for you. Everything that your devices can do is the result of thousands of people working together to make the complex instructions for it to work. But to do all of these things, as we said earlier, computers need to do things with information you give it, and then store it somewhere. That's why computers have something called a hard drive, which is responsible for storing all of the data that they get. You can think of a hard drive as kind of like the brain of the computer, because it's responsible for storing all of the data that the computer might need to do all of the things that it needs to do. But really, how do computers actually store information? Like, how would a computer remember the word pizza? Well, computers don't work exactly the same way the human brain does. They can't understand English or store the word as it is. They have to use something called the binary number system. This is just another way of representing numbers. We as humans like to use something called the decimal number system in everything we do, but computers have been designed to do it differently. In our base 10 system, everything is, well, based on the number 10. If you take any number, say 904, the way we think about the number is through place value, which you may have learned about a little in school. Basically, place value tells you about the number or the value of a digit depending on where it is in a number. Thinking about this is helpful when we talk about binary numbers and what they mean for computers. In the number 904, there are three places, moving from right to left: the ones place, the tens place, and the hundreds place. Since there are 4 ones, 0 tens, and 9 hundreds, we can multiply the value in each of those places to figure out the total value of the number. We do 4 times 1, which is 4, 0 times 10, which is 0, 9 times 100, which is 900, and then we add everything up to get 904. In the same way, the number 1432, 1432, can be thought of as having 2 ones, 3 tens, 4 hundreds, and 1000. Also, if you think about our base 10 number system, we have a lot of digits. 10 of them, in fact. 0, 1, 2, 3, 4, 5, all the way up to 9. But in binary, by the way, which means 2, we only have 2 digits, 0 and 1. The language of computers is ultimately binary. Since computers can't understand English like we can, they can only understand human information as long strings of binary numbers. For example, the word pizza from earlier is actually a very long binary number. But how does this actually work? Well, in the world of computing and computer science, all the different characters or single letter strings are assigned a certain number. You can think of the word pizza as a set of 5 characters: P, I, Z, another Z, and an A. It just so happens that P is assigned the number 112, and 112 in binary is the same binary number as you saw earlier: 0111 0000. The same thing happens for each of the other letters in the word. Each letter in the word has a certain number that it is connected to, and then that number is converted to a binary number. For example, A in the letters in the alphabet becomes 97 in base 10, which then translates to 011 00001. So essentially, if you wanted to make a computer store the word pizza, it would actually store it as this: 011 000 011 01001, and so on. And now you've learned the most important thing about computers and data. But you're probably thinking, how can some long strings of ones and zeros be the same as a number like 97. That's where converting from one number system to another comes in. When we're converting from binary to decimal, we have to look at each of the digits in the number and see what their value is. Let's take a look at the binary number 10110001 right over here. The most important thing to remember is the value of each of the places in binary. When we go from right to left, the value of each place gets multiplied by 10 in base 10. In the same way, in binary, the value of each place gets multiplied by 2 because we are in base 2. In 10110001, there are 8 digits total, starting on the right with 1 and doubling every time you go left. For example, if you see over here, it'll show you that the 1 actually corresponds to a 1. There's a 0, which corresponds to a 2 in base 10. This is a 0, which corresponds to a 4, and so on. We will see that a 1 corresponds to a 16 in base 10, a 1 corresponds to a 32, and a 1 corresponds to a 128 in this number, 10110001. So when we start in the rightmost place, we start off with a value of 1. Then, when we go left, we double and become 2. Then we double again and become 4, and then we become 8, and then 16, and so on for as many digits as there are in the number. Now, all we have to do is multiply the digit in each place by the number of its value. Starting with the digit at the beginning of the number, we will do 1 times 1. Then for the second digit, 0 times 2. For the third, 0 times 4. For the fifth, 0 times 8. 1 times 16. 1 times 32. 0 times 64. And finally, 1 times 128. And at the end, we add it all up to get a number in base 10, which is going to be 177. That's going to be 128 plus 32 plus 16 plus 1. Note that we only counted the numbers which had a 1 on top of it. So 128 had a 1, 32 had a 1, 16 had a 1, and the 1 had a 1. And if we add all these together, we get 177. Since the best way to learn is to actually practice, let's do some exercises. As a review, let's practice some binary to base 10 conversions. Pause the video so you can practice. Here are the binary practice 1 answers. This is 011001, which means that there is a 1 in the 16's place, a 1 in the 8's place, and a 1 in the 1's place, adding up to 25. Here, it is only a 1 in the 1's place, which means it is 1. Here it is 1011, which means there is a 1 in the 1's place, a 1 in the 2's place, and a 1 in the 8's place, adding up to 11. Here, there is a 1 in the 8's place, a 1 in the 4's place, and a 1 in the 2's place, adding up to 14. And here there is a 1 in the 32's place, adding up to 32. Now that you've learned some interesting skills, I think it's time for an adventure. You're an agent working for the FBI. You have been following a crazed psychopath who is on an evil mission that you must stop. After a long and grueling quest to defeat him and his cronies, you discover a massive room full of locked treasure chests. A cryptic sign on the wall says, "All of these chests full of treasure, but only one unlocked. Which one will it be?" Upon further reading, you see that there are 3 clues that will lead you to the correct chest, but there is a hidden message in the binary numbers you are given. Can you crack the code? The instructions for this adventure. Convert the binary numbers to base 10. Convert the base 10 number to an ASCII letter. Do all of the letters to get the word. Put the words together to make the completed clue and find the right chest. Here's a table that you will need to do to get the second conversion. Refer back to this whenever necessary. This will be used for converting decimal to ASCII letters. Clue number 1. Please convert this to the base 10 system and then convert that to an ASCII letter. Pause the video. Clue 1 and the answer. The first evaluates to 2 plus 16 plus 32 plus 64. This is because there are 1s in these places corresponding to the binary values. This adds up to 114. The next one adds up to 101. And finally, the third one will add up to 100. Clue number 2. Pause the video so you can solve this, converting this binary to base 10 and then to ASCII. This is clue number 2. The first binary letter will convert to a C in ASCII, and this is because 1 plus 2 plus 32 plus 64 becomes 99, and that becomes a C. After that, the 1 plus 8 plus 32 plus 64 becomes a 105, that becomes an I. Third, 2 plus 16 plus 32 plus 64 equals 114, and that corresponds to an R. And so on until we get the word circle. Similarly, for the previous clue, we could have gone and checked what the ASCII values were corresponding to these numbers. If we did, we would have found out that this would be equal to R, this would be equal to E, and this would be equal to D. So it would be RED, becoming red. This is the third clue. Pause the video so you can convert this binary to a base 10 decimal, and then from there convert that to ASCII. Assuming you finished, let's move on. The answer for this is going to be sad, and it's going to be for the same reasons as before. We are looking for the 1s in the values that correspond to the binary values. And here it's going to be 1 plus 2 plus 16 plus 32 plus 64, that becomes 115, which is an S, and so on until we get the word sad. So which one is a correct treasure? Can you find it? We have 3 words, red, circle, and sad. You guessed it, it is this treasure right over here. This treasure it's red, it has a circle, and it has a sad face, which means this is a treasure that's unlocked. Tips for converting to binary. Here's a couple tips to convert, so it makes it easier for you. First, think of the largest binary value that can go into the number. That means it could be 1, 2, 4, 8, 16, whatever. Subtract that value from the number. Write down a 1 that represents that binary value. Divide that binary value by 2. Then check if that is less than the new number. If it is, then put a 1. Otherwise, put a 0. Proceed with steps 4 and 5 until the binary value is 1, and including 1. That is the binary representation of the original number. Now here's some more binary practice. Pause the video so you can finish these conversions. Assuming you had to go at it, let's check them out. The first one is 9, and that means that there is an 8, which is less than 9, and subtracting 8 you get a 1. So you have 1 times 8, and you have 1 times 1, which adds up to binary as 1001. Then over here you have 32, which is already a binary value, so that's going to become 1 times 32, which is 100000 in binary. 63 is 1 times 32 plus 1 times 16. Every time we're subtracting the largest value. So here we subtract 32, and after we subtract 32, we get 31 in base 10. And now subtracting 16 from that, and so on, we will get the number 111111. If you go and check this, all of these numbers do add up to 63. 98. Using the same rules as shown before, we will get we will get the binary value as 110010. And here 135 will become 10000111. So Let's talk about binary. We already talked about binary and how computers only understand ones and zeros. So the real question is, how do we communicate with computers and give them instructions? This is the purpose of programming languages. There are many languages, and they all allow us to give instructions to a computer. It would be absolutely crazy if we wrote all of these programs directly in ones and zeros just to give a computer a command, because it takes such a long time to do so. Programming languages make it easier for humans to understand and write code. When you run or execute your program, your code is converted to binary by the compiler, and the computer can understand what you wrote. What are the best programming languages? There are tons of programming languages out there, including Java, Python, C++, JavaScript, C Sharp, and many more. Don't worry if you've never heard of any of these, but you might be wondering, what is the best programming language? Well, there really is no best programming language, although many people tend to argue over it. Programming languages are like tools. It depends on what your task is. Just like how there is no best tool. A screwdriver is good at doing one thing, while a hammer is good for a different purpose. You could use a screwdriver to hit something instead of a hammer, but it is better to use a hammer. In the same way, a hammer can't really replace a screwdriver, even though it's better at hitting things. So in the end, it just depends on what you want to do. If you wanted to make mobile games, you would use languages like Swift or Java. If you wanted to make games, you could use languages like C Sharp. If you wanted to make websites, you could use JavaScript. Programming and computer science are very broad fields. So don't worry if you don't know what you want to do yet, but you should first understand basic programming concepts that are important for all languages, which is what this course is meant for. Finally, we're going to talk about one last topic, and that is how computers communicate. Just like how a house has its own address, like 123 Main Street, each computer has a unique IP address which gives the computer's identification on the internet. The internet is billions of computers connected together in one network, which is why internet is short for internetwork. Computers communicating is similar to people communicating. Let's use the example of writing a letter to someone. First, you prepare what you want the letter to say, which is like preparing the data you're going to send. Then you get the address of the person you want to send it to. The computer will get the IP address of the person you want to send to depending on what you're asking it to do. Then, your computer gives the data and IP address to your router, which is a physical device in your home or in the neighborhood. The router will then send that data off and soon it will arrive at another computer. This is happening every second of every day all around you.
So you might ask, where do we program? Well, in Java, we can program in something called an IDE, or Integrated Development Environment. And an IDE allows you to write and run your code in Java. And there's many different types of IDEs, but we're going to be using something called BlueJ. And the reason we're using BlueJ is because it's designed for beginners, so it's very easy for you guys to start out with BlueJ. Installing BlueJ. So basically, you can go to your web browser and your search engine of choice and go to bluej.org, search that up, and you will be able to go to the install page. So once you go there, you'll be able to download based on your operating system. So if you're using a Windows computer, you can download the Windows version. If you're using Mac OS or OS X, you can download that version, and so on. So that is the end of this class, Java Class 1.1, How Computers Work. If you have any questions regarding this presentation or the concepts covered, please ask in our Discord server.